you by thesis123.com. I learn and teach online.
Here's the next question, number 8. The solution of the differential equation for t is greater than 0, y double dash t plus 2y dash of t plus y of t is equal to 0 with initial conditions y of 0 is equal to 0 and y dash of 0 is equal to 1 is, we have our 4 options. The question also tells us that u of t denotes the unit step function. Okay, so we have to solve the given differential equation using the initial conditions given. So I'll just write that down over here. So our differential equation is y double dash of t plus 2y dash t plus y of t is equal to 0. Initial condition given to us, y of 0 is equal to 0 and y dash 0 is equal to 1. So these are the initial conditions. Okay, so a very good way of solving this differential equation is to use Laplace transforms. So to use Laplace transform, it is important that we know our formulas. So for this question, I'm going to write down the basic formulas over here on the side. So we'll be using first Laplace transform to convert this in the S domain and then use inverse Laplace to bring it back in terms of the exponential function. So just to give you a review of all of this, I'm going to write down only the formulas that we'll be using for this equation. So the first one is the Laplace of f dash t. Since we are dealing with differential equation, we have both first derivative and second derivative. So the Laplace of the first derivative is s f dash of s minus f of 0. The second equation is for f double dash t, and that's s square f dash s minus s f of 0 minus f dash of 0. So this is our formula for the second derivative, Laplace transform of the second derivative. Then we will also be using inverse Laplace. So the inverse Laplace of 1 by s minus a is e power at. Also Laplace inverse of 1 by s minus a whole square is t into e power at. Now I want you to keep all of these 4 formulas in mind. Okay, it's quite important because most commonly these are used. So I'll just take another sheet of paper here and we will begin with the solution. Okay, I think I have it straight. All right. So let's begin with the differential equation given to us. So we have y double dash of t plus 2y dash of t plus y of t is equal to 0. I'll put down the initial condition here so that we can refer to it when we need it. Okay, so we are going to apply Laplace transform. On both sides on the equation. All right, so we have Laplace of y double dash of t plus 2 times Laplace of y dash of t plus Laplace of y of t. Okay, so double dash of t. Now we saw the formula already. So here we will have s square y bar minus s y of 0 minus y dash of 0 plus, now we are writing the Laplace of this, so it's 2 into Laplace of y dash t is s y bar minus y of 0 plus Laplace of y of t is y bar. Okay, so we have this. Now you should know that y bar is actually just Laplace of y. That's the general notation. Instead of writing Laplace of y, we write it as y bar. Okay. So next. Now that we have all of this, let's substitute the initial conditions that's given to us. Y of 0 is 0. So y of 0 is 0 over here. So this term becomes 0. Y dash of 0 is equal to 1. So here this becomes 1 and this again is 0. So let's just substitute. Y square s square y bar minus 0 minus 1 plus 2s, multiplying that, y bar, this is 0 plus y bar is equal to 0. Okay, so this is what we have now. Next, I'm going to take y bar common and take the constant term to the other side. So I'll have s square plus 2s plus 1 y bar is equal to 1. Now y bar would be 1 divided by s square plus 2s plus 1. If we were to factorize this, we get s plus 1 square. So we have s plus 1 square. And recall that I have written the formula here for 1 by s minus a whole square. We'll be using that in the next step. So we are going to apply Laplace inverse on both sides. So I think I'll just flip this over and write it down here for you. Okay. So applying Laplace, inverse Laplace on both sides. Okay, so we have here y bar is equal to 1 divided by s plus 1 whole square. So let's apply Laplace inverse to this. Okay, so Laplace inverse of y bar is y of t. That's because y bar, like I said here, I showed you here that y bar is Laplace of y. So L inverse of L of y is y. So I'll just put that down. So L inverse of y bar is y, that's y of t, is equal to, so here we have 1 by s plus 1 whole square, and we saw from the formula that 1 by s plus a whole square, the Laplace inverse of that is t into e power minus t. It is minus t because this is 1. So that's at. So substituting 1 in terms of a, in place of a, we get e power minus t. So because the question talks about unit step functions, so we would multiply this with u of t. So this gives us the final answer of y is equal to t e power minus t u of t. This is the final answer, and let's take a look at which option it matches with. It matches with A. So A is the right answer here. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.